So picture this. You've just written, like, perfectly clean code. I mean, it is absolutely flawless.
Oh, the dream scenario.
Right. You run your linters, your pilot score is a pristine 10.0 out of 10. Every variable is named beautifully.
Cyclomatic complexity is basically zero.
Exactly. So you confidently push it to production, and then
Oh.
total disaster.
This completely breaks.
It either shatters the system's observability or, it triggers this massive silent cloud billing spike and you're just sitting there staring at your screen.
Wondering how mathematically perfect code just caused a complete system meltdown.
Yeah. I mean, clean code is like having a perfectly tuned engine sitting on a test block. It hums beautifully, right?
Mm.
But without architectural context, you have no idea if that engine is about to be dropped into a Ferrari or, like, a submarine.
And that right there is the core vulnerability of modern software development.
Yeah.
Right, we're heavily trained to believe that structurally sound code is inherently safe code.
But it's not.
No, not at all. It's a massive blind spot,
Yeah.
especially now that we're, integrating AI into the engineering pipeline. If an AI doesn't know what vehicle it's supposed to be fixing, it'll just confidently optimize your submarine for highway speeds.
That is such a good way to put it. Well, welcome to the deep dive, everyone. Today, we're exploring this really fascinating and honestly game-changing piece from the DEV community by Alexander Tootin.
It's titled Architecture Documentation as a First-Class Engineering Asset.
Yeah, and we're also going to dig into the really spirited high-level debate that totally erupted in the comments section.
Which is where the real gold is, Anna.
Oh, for sure. So our mission today is to uncover how combining AI with collocated architectural docs transforms these automated tools. We're talking about going from simple, typo catchers to highly advanced system-level reasoning engines.
Because if you just point an AI at a repository of raw code,
Yeah.
you really aren't giving it the capacity to reason about the system at all. It's like asking a senior engineer to do a security review while locked in a closet.
With zero access to the design docs.
Right. And this hits on the myth of self-documenting code. There's this persistent assumption that if your code is well-structured, it just explains itself.
Which is mostly a lie we tell ourselves.
Totally. Tootin's piece breaks down a fundamental truth here. Code only explains how a system executes. It details the precise sequence of operations.
But the architecture documentation explains why the system exists in the first place, right?
Exactly. The why, the risk profile, where security boundaries lie. Without the why, the AI is completely in the dark. It sees an API call, but it doesn't see the zero trust security policy that call is supposed to enforce.
Okay, let's unpack this. Because to fix this blind spot, the author did something highly unorthodox.
Oh yeah, the push-up experiment.
Yes. So he has this Google Cloud environment, right? Dozens of microservices on Cloud Run, storage buckets, Vertex AI gateways, and the existing documentation was basically a graveyard of scattered rei ideme files.
As is tradition.
Right. So he brings in this agentic AI coding assistant called Anti-Gravity, powered by Gemini 3 Flash and Claude Sonnet 4.6. He gives it a strict documentation standard, points it at the code base, and then literally steps back and does push-ups off screen while the machine works.
Which is just a great visual.
Mhm.
But while he was doing that, the AI was executing this massive autonomous discovery phase.
Yeah.
It wasn't just summarizing text.
Right. It was actually tracing dependencies.
Yeah, it read the source code across different repositories, cross-referenced implementations, and iteratively wrote these highly structured architecture.md files.
And it didn't just spit out some rambling wiki page. It generated a really strict machine-readable template.
4 distinct parts, right?
Yeah. First, the intent, like the concrete business reason the service exists. Second, the design principles, which explicitly states trade-offs, latency targets, statelessness, stuff like that.
And third was the interaction diagram, which
What?
was super impressive.
Yeah.
The AI parsed the network calls and translated them into mermaid syntax.
Wait, so it made actual visual flowchart.
Yep. Real flowcharts showing service-to-service communication that rendered directly in GitHub. It turned abstract logic into a deterministic map. And the final piece was the LLM context block.
Okay, that context block is wild. It's documentation written by a machine, specifically optimized for other automated agents to read.
Bypassing human readability entirely.
Yeah, it prioritizes token efficiency for the next AI. But, my initial pushback here was about the actual utility. Like, auto-generating docs while working out is a fun party trick, but does it actually change the nature of the code base?
Well, it does, because it creates an entirely new paradigm of automated review. Collocating those docs, meaning they live right next to the source code, allowed the author to build an AI-powered quality gate.
Using Vertex AI and Gemini, right?
Exactly. And he deployed it on Cloud Run, so it's serverless. It only spins up when a merge request is triggered.
So it's incredibly cheap. We're talking like pennies per review.
Pennies. But what's fascinating here is how it works. The quality gate constructs a prompt, merging the code diff with that architecture.md file.
So it's not just checking syntax anymore.
No, with that context, it evolves from a static linter into a system-level reasoning engine.
And to prove this, he shared two massive catches. Bugs that had been sitting there for months, totally undetected by linters, unit tests, and human reviewers.
The first one is a perfect example of code being locally optimal but systemically catastrophic, the distributed tracing blackout.
Right, so there was this routing service running middleware that explicitly stripped incoming trace headers from HTTP requests.
Which, to a human reviewer or a regular security tool, looks like a best practice. You're sanitizing inputs, right? Preventing injection attacks.
Yeah, a human sees input sanitization and just clicks approve. But the AI caught it.
Because it had the docs.
Exactly. The AI saw the docs required end-to-end X-Trace ID propagation for Google Cloud Trace observability. So the AI intercepts the diff and essentially says, hey, you aren't isolating a threat, you're severing the entire observability chain.
Which is incredible. A normal linter only sees valid syntax. Catching this requires intersecting code behavior with documented intent.
And then there was the second catch, the silent storage leak.
Oh, this one is so common.
Right. A media service intentionally skipped cleaning up temporary audio files in a Google Cloud storage bucket, probably just to keep the function simple and avoid, like, accidental deletion errors.
But the AI cross-referenced that against the architectural principle of data minimization. It flagged it as a severe security and FinOps violation.
Because accumulating user audio files forever is a massive attack surface.
And a compounding silent cost.
Yeah.
The AI deduced the financial implications of a missing line of code based purely on the design principles.
That's the crazy part. Scanning isolated functions never catches the absence of an action. But of course, theoretical AI solutions usually hit a brick wall in real-world team dynamics. And the comment section brought this up immediately.
Oh, they did not hold back. Engineering teams have been burned by the promise of perfect documentation for decades.
Yeah, commenter Mykola Kondratyuk pointed out the stale docs problem. He said auto-generated docs are a snapshot, not a contract.
Right. If the docs get 3 sprints behind, the AI just fails silently.
And we all know just remember to update the docs has a literal 0% success rate. So the author built in a forcing function. The quality gate actually blocks merge requests if you change the code without updating the docs.
He even moved the check into his local IDE, so developers get rejected before they even open a PR.
Okay, here's my pushback on that, though. If you make it a hard blocker, developers are going to game the system. What stops someone from just adding LGTM into an architectural decision record to unblock their build?
Which is exactly how forcing functions devolve into theater. But this is where commenter Thomas Landgraf jumped in with a really tactical solution.
The guy with 40 years of dev experience?
Yeah, he's seen every documentation trend fail. His solution is to make the docs deeply machine-readable using hierarchical YAML front matter, and he connects it directly to the dev environment using an MCP server in VS Code.
Right, SpecLin. Model Context Protocol. So instead of just dumping a huge markdown file into the AI and hoping it doesn't hallucinate, it treats the specs as queryable tools.
Exactly. The AI quality gate actively interrogates the architecture like it's a database. If it's reviewing a caching layer, it can ask the MCP server, what is the global latency requirement here? And get a deterministic answer.
That completely changes things. It turns static text into an active gatekeeper. And then Archit Middle suggested making architectural decision records ADRs a literal CI precondition.
Right. If the Azure link field is empty on a PR, the build fails, which applies friction only when the change actually touches a system boundary.
But here's where it gets really interesting. Because even with queryable docs, we have a massive blind spot. Muggle AI brought up this concept of adversarial ignorance.
Such a brilliant term. The AI only reviews what the team thought to document.
Exactly. If you didn't anticipate a weird user journey, it's not in the doc, and the AI won't check for it. It's like blindly following a GPS navigation system.
You're just driving straight into a lake because the map says there's a road.
Right. If the map is wrong, the AI quality gate confidently enforces a totally fictional standard. Commenter Peace Binflow called this the inverse failure mode.
Yeah, and AI trusting aspirational documentation is arguably more dangerous than having no AI at all. It gives you a false sense of security.
Which leads to this huge philosophical debate between Mykola and the author about trust boundaries versus supply chain.
This is the existential question right now. As we rely on agentic AI, what are we more terrified of? Mike Kola argued trust boundaries are the biggest concern. An agent doing the wrong thing because of bad context fails silently.
The human trusts the machine trusts the doc, and nobody's actually verifying reality.
But Alexander countered that supply chain vulnerabilities are just as bad. What if the AI model itself was trained on poisoned architectural patterns?
With traditional software, you can run vulnerability scanners, you can audit dependencies.
But what happens when the scanners and auditors are also written by AI?
Exactly. You have AI writing the docs, AI reading the docs to review the code, and AI building the auditing tools that check the reviewers. We're staring into this infinite loop of machine-machine trust.
A completely closed recursive loop. It's wild to think about.
So what does this all mean for you listening? Whether you're managing a dev team or just trying to understand AI's role in engineering, what's the ROI here? Alexander calls it the $10,000 architecture.md file.
The ROI is that collocating these docs is the ultimate force multiplier. Catching a silent data leak in a CI review that cost pennies is infinitely better than finding it during a catastrophic compliance audit 6 months later.
Providing the why unlocks the AI's actual analytical power. You can't just give the machine a microscope to look at bricks. You have to give it the blueprints for the house.
Well said.
We've covered a ton of ground today, from the push-up approach to adversarial ignorance. But before we wrap up, we want to leave you with one final thought based on that supply chain debate.
Yeah, think deeply about this. If AI agents are generating the architecture documentation and other models use those docs to review code, and eventually AI builds the auditing tools checking the reviewers, where does the human root of trust actually lie? Are we just a few incidents away from an infinite loop of AI trusting AI?
That is definitely something that makes you look at your perfect 10.0 pilot score a little differently. Clean code is great, but without context, you're only seeing a fraction of reality. Keep your architecture documented, keep it collocated, and maybe let the agents handle the heavy lifting while you get some push-ups in. Thank you for joining us on this deep dive. Keep questioning the map, and we'll catch you next time.